Right, welcome back YouTubers. So today I'm going to be teaching you about differentiation. So I've drawn a little curve here on a graph and we're looking at a point about 1 and minus 1, and we're trying to determine for this point what the gradient would be at this point, which would be a line at a tangent there coming straight across. So how would you go about this? So you've done some work with graphs, and how would you go about determining this? Well, I'm going to sort of magnify this in a bit here. So we're going to have our curve, which is going to be sort of when that's really zoomed in there. And you could say, well, you could take in our y direction, and we could also take in our x direction here. And you could have a look and tell me that this space is dx across here, this width, which is the difference from a point here, say x1, and a point here, x2. And you could tell me that this distance here is dy, or delta y, sorry, and that's some point from y1 and y2. And you could find the ratio of these two, and you'd find some line like that there. That isn't about our point, which is somewhere around here. So then what you do is you go, right, well, we can get a better approximation, we can get a bit closer. We can do something like this. We can go in like that. Well, this is our new dx, and this is our new dy. But again, you're going to get some line like that. It's getting close, but you know, we're still not quite there. So again, we can go even closer. We can get right down here. dy, dx. We've got something really small like that, and you get another line going across there. Now, for the width of these pens, you can't really see that's going over a line now, but it's still not quite right. So you can keep zooming in and zooming in, and if we keep zooming in as far as we possibly can, this is where our differentiation comes from. This is an infinitesimally small point that we're taking for difference between y and x. So if we take a function now, remembering from our function series that we say if we have y is equal to, and we'll just make up, this curve's not going to be this function, but we're just going to make a function now, and we're going to say we have 2x cubed plus, I don't know, we'll say 2x minus 4. This is our curve. And we can also remember, we can say this is equal to some function of x, which we'll come to when we're discussing notations for differentiation. So if we were going to take, we could say the derivative of this is how we differentiate this. What we do is we say we differentiate y. And now technically, if we're being correct, the d is always very upright. It's not sort of a sideways d, but that's a differential d, but it doesn't really matter too much. And we say we differentiate it with respect to x. And then some rules come in of what we do to differentiate things. And we'll be covering many of these different rules, but the best way to do is look up a table, really, of differentials, and you sort of see how to differentiate various different things, so there's no point me going through all the different ones. But I'll show you the first very basic one, which is if we were to differentiate just our little polynomial term here. So what we do is we take a look here and we say, right, we've got to deal with all our x terms. So for an x cubed, or any x to any power, we multiply the power by whatever's before. So we have our 2, we multiply it by 3, and we have our x, and then we knock our power down by 1, so that goes down to 2. So for the next one, we have our 2. This is effectively x to the 1. So this goes by 1. But our x is x to the 0 now, which we know is 1. And there's no x term on our 4, so our 4 just disappears. Then we could write this out to be equal to 6x squared plus 2. And now if you were to find any value on this curve, anywhere through, you could find the gradient by inputting it into here. So if you wanted to find it at x equals 9, or something like that, then you just put your value in here and it'll work. You wanted to find it at, like we're doing here, x equals 1 then, you just put 1 into here, so we have this is equal to 6, 1 squared is 1, plus 2, so it equals 8. And this is how we do differentiation.